Here we're going to start with a new chapter, that is triangles. Now in this chapter we are going to basically study about the congruency of triangle. But before knowing the concept of the congruency, let's talk about some of the terms which we are going to use in this chapter. Now the very first term which we are going to discuss over here is median. And here the median is a line which joins the center of opposite side with this vertex. So the line joining the vertex to the center of the opposite side is known as median of the triangle. And the line which is perpendicular from here to the opposite side is known as altitude of the triangle. Now if we make all the three median of the triangle and the point where all the medians are going to coincide is known as centroid of the triangle. Here you can see in this triangle all the medians are coinciding at this point. So this point is known as centroid. Now the point where all the altitudes meet is known as orthocenter of the triangle. Now here we are going to discuss the various ways by which we can prove the triangle as a congruent. So for proving the triangle as a congruent, we are having 5 different ways. And the very first one is SSS, which is the abbreviation of the side, side and side. In this congruency criteria, we have all the 3 sides of the equal length. And the next one is SAS, which is the abbreviation of the side, angle, side. Here, the 2 sides are of equal length and the angle which contains the 2 sides is of equal measure. Then in the third one, we are having ASA. Here, the 2 angles are of equal measure and the side which contains the 2 angle is of equal length. Then the fourth one is AAS. Here the 2 angles are of equal measure and the side apart from the one which is containing the 2 angles is equal. Then at the last one we are having RHS. In this one we have one right angle, the hypotenuse and any one side equal in both of the triangles. If we have been given that two triangles are congruent, suppose we take the triangle ABC is congruent to triangle PQR, in that case we get all the corresponding sides and all the corresponding angles equal to each other. Here the corresponding means this AB is equals to PQ, BC is equals to QR and AC is equals to PR. Also angle A will be equals to angle P, angle B will be equals to angle Q and angle C will be equals to angle R. So here we are having 6 things equal if we prove any of the triangles as congruent. And the reason for all of this is CPCT. That stands for corresponding parts of congruent triangles. Now let's start with the exercise 9.A. And we are going to deal with the question number. Now here in question number 2 we have been given that O is center of the circle and this P is midpoint of AB. And we have to prove that OP is perpendicular to AB. Now for this, very first of all, we are going to do a construction by joining this O with A and B. Now after that, we are going to prove these two triangles as congruent. For that, the proof. So in triangle OPA and OPB, make one thing very clear that you should be having a proper naming of the triangle. Here we are going to start from here only, that is OPA. If this triangle is OPA, then this one will be OPB only, because OA is equals to OB, this radius of the triangle, OP is equals to OP, that is common, and AP equals to BP, because P is midpoint of the triangle. So here we are going to take in triangle OPA and triangle OPB. Then OA equals to OB, radii of same circle. Then OP equals to OP common. Then AP equals to BP, the P is midpoint of AB. As in this triangle, all the 3 sides are equal. So triangle OPA is congruent to triangle OPB by S, S and S criteria. Now, as we have proved the triangle as a congruent, then all the corresponding parts will be equal. So here we have to prove this angle as 90 degree to prove that this is a perpendicular one. So angle OPA is equals to angle OPB by the region of CPCT, that is corresponding part of congruent triangle. Now we are going to take this equation as equation number 1. Now we know that the sum of these two is 180 degree as they are linear pairs. Now we can place the value of OPA or the OPB from equation number 1. So from equation 1 we get twice of angle OPA equals to 180 degree. And on solving this we get angle OPA equals to 90 degree. And here as we see that we are having OPA as 90 degree, therefore OP is perpendicular to AB. That implies OP is perpendicular to AB. Hence proved. Now we move to question number 3. Here in this question again, we are having a circle with the center as O, and this OP is perpendicular to this chord AB. Now we have to prove that AP is equals to BP. So very first of all, we are going to join this A to O and O to B by the help of construction. Now after that in proof, we are going to prove the triangle OPA is congruent to triangle OPB. So in triangle OPA and OPB, this OP is common. OA equals to OB as the radii of the same circle. Then OPA equals to angle OPB as it is of 90 degree. Now, while proving this two triangles congruent, we have used this right angle, that is angle OPA. Then this side OA, which is the hypotenuse of this triangle, and this side OP, which is a other side of the triangle. So here we have used the criteria of RHS to prove the two triangles congruent. Triangle OPA is congruent to triangle OPB by RHS, and AP is equals to BP by CPCT. Hence proved. Now here in question number 4 we are having a triangle ABC and D is midpoint of the side BC. Now we have to join this AD and then extend or produce this AD to the point E such that this AD is equals to DE. Then we have to join this. Now here in this question we have got D is midpoint of the side BC and this AD equals to DE, and we have to prove this AB equals to EC. Also this AB is parallel to EC. So very first of all we are going to prove these two triangles as congruent. So in triangle ABD and triangle, here we have taken ABD. This means it will be ECD. Now here we can take BD equals to CD as it is midpoint. Then AD equals to ED, which is given to us. And the third thing we can take this angle equals to this one because these. And the third thing we can take this angle equals to this one as they both are vertically opposite angles. Now while proving them congruent, we have used this side and this angle. So it will be side, angle and side. After that we have to prove this AB equals to EC. So as we have proved these two triangles congruent, so AB will be equals to EC as the corresponding part of congruent triangle. Also we have to prove this side is parallel to this one. So very first of all, let's take this angle as angle 1 and this one as angle 2. Now these two angles will be equal by the corresponding part of congruent triangle. So here angle 1 equals to angle 2 by CP CT. As these two angles are also interior alternate angles, therefore this AB will be parallel to this one. Hence proved. Now let's move to question number 5, first part. Here in this one we have been given with a triangle ABC in which angle B is equals to angle C, and we have to prove the perpendicular from the midpoint of BC, that is point R, to the sides AB and AC are equal. So here in this triangle we have been given with the angle B equals to angle C, R is the midpoint of BC, and RP and RQ are perpendicular to AB and AC respectively. And we have to prove this RP is equals to RQ. Now for this we are going to prove the triangle RPB is congruent to triangle RQC. So in triangle RPB and triangle RQC, this RB will be equals to RC as R is the midpoint of BC. Then angle B will be equals to angle C. It has been given to us. and angle RPB will be equals to angle RQC, 90 degree each. Now, while proving these two triangles congruent, we have used this side, this angle, and this angle. So, the angle, and side. So here RPB is congruent to triangle RQC by AAS, and RP is equals to RQ by CPCT. Hence proved. Now here in the second part of the question 5, we have been given with a triangle ABC in which angle B is equals to angle C, and we have dropped a perpendicular from B to AC at BQ and from C to the line AB as CP. Now we have to prove this BQ is equals to CQ. So in triangle BQC and triangle CPB, in triangle BQC and triangle CPB, here the BC is common in both of the triangles. So BC equals to CB, common. Now the next one is angle C equals to angle B. So here in triangle BQC, angle C is there. In triangle CPB, we are having angle B. So angle C will be written over here equals to angle B on this side. And that too also been given to us. And then we are having angle BQC, that is angle Q, and angle CPB, that is angle P. They both are equal because they both are of 90 degree each. Now these two triangles are congruent. Now to prove these two triangles congruent, we have used this angle, and then this side. Means the two angles are here and this side is over here. So it is AAS. And this BQ is equals to CP by CPCT. Hence proved. Now in question number 6, we are having a triangle ABC and the perpendicular bisector of all the sides are meeting at I. And we have to prove that AI is equals to BI equals to CI. Now to do so, we are going to prove the two adjacent triangles as congruent. Either we are going to prove this or this one. Now here we have to prove that AI equals to BI equals to CI. So we are taking the triangles IXB and IXC. So in triangle IXB and triangle IXC. Here IX is equals to IX as common. Then BX will be equals to CX as XI is perpendicular bisector of BC. Then angle IXB will be equals to angle IXC as 90 degree each. So these two triangles are congruent by using the side, this one, then we have used this angle and then this side. So it is SAS. And now we can prove this BI equals to CI by CPCT. Now, as we have proved this BI equals to CI by proving these two triangles congruent, similarly we can prove these two triangles also congruent and we'll be able to prove this AI equals to BI. So here we are going to use similarly. AI equals to BI. Now we can take this one as equation number 1 and this one as equation number 2. And we can write over here from equation 1 and 2, we get AI equals to BI equals to CI. Hence proved. Now in question number 7, we have been given that there is a line AB which is bisected by a point P over here, and from P we are getting a line PQ which is perpendicular to this line AB, and we have to prove this AQ is equals to BQ. Now here we can take the triangle QPA and triangle QPB. So in triangle QPA and triangle QPB, Here QP is equals to QP common. Then AP will be equals to BP because P bisects AB. And angle QPA equals to angle QPB, 90 degree each. So triangle QPA is congruent to triangle QPB by, we have used this side, we have used this side and this angle. So it is SAS. And this QA will be equals to QB by CPC. Hence proved. Now here in question number 8 we have been given that angle BAC has been bisected by line AP and M is any point on this line AP. We have to prove that the perpendicular drop from this point, that is MY, is equals to MX. Now to prove this, we are going to take the triangle MXA and MYA and we are going to prove them congruent. So in triangle MXA and triangle MYA, here MA equals to MA common. Then angle MXA will be equals to angle MYA, 90 degree each, and angle MAY will be equals to angle MAX because AP bisects angle A. Now while proving these two triangles congruent, we have used this angle and this side. So it is AAS. So triangle MXA is congruent to triangle MYA by AAS. Now as these two triangles are congruent, so these two sides will be equal and MX equals to MY by CPCT. Hence proved. That's all in this video. Thank you.